Hello, am I audible? माझा आवाज येतोय? अपर्णा, रुपाली, पूजा, अंकिता, रसिका. Can you hear me? Can you hear me properly? अनम्यूट करून बोला वाटलं तर. ऍक्च्युली मी आज व्हिडिओ बंद ठेवणार आहे बिकॉज व्हिडिओ जर स्टार्ट केला तर नेटवर्क इश्यू स्ट्रॉंग येतो. मोबाईल वरती हॉटस्पॉट वरती कनेक्ट केलेलं आहे मी, सो ड्यू टू दॅट रिझन. ठीक आहे. माझा आवाज प्रॉपरली येतोय का? अनम्यूट करून बोला. कोणीतरी सांगा.
Yes, sir.
ओके, फाईन फाईन. Okay, so very warm good morning to all. Yesterday we discusses on the topic of theory of thin film growth, and primarily we also start some of the points on the basis of uh, thin film growth. Okay, so today we again try to understand that concept of theory of thin film crystal growth, and what will happen exactly if we deposit some kind of crystal onto the substrate. Okay, it means that which type of process was happen, that concept we will recalling once again. Okay, so we totally aware that what is mean by crystal, and that point we already covered in the subject of solid state physics. Am I right? So that the crystal is nothing but a what? The crystal is a solid material whose constituent atoms, molecules or ions are arranged in orderly repeating pattern extending in all three dimensions. Getting my point? So that type of crystals are we want to deposit onto our substrate. Okay, and that's substrate we will deposit our material on layer by layer also. Okay, and that things are also possible by using the different techniques such as chemical vapor deposition technique, laser ablation technique, physical vapor deposition technique, Dr. Blade method, Lagmuir budget method. These are the method which we will deposit some kind of material onto the crystal. Okay, but keep in your mind that keep in your mind that the crystal growth process is not that much easy stage. Getting my point? The crystal growth method or crystal growth process is not that much easy stage, because that's why here calling the it is a major stage. Look at here, I have written one word, that is major stage, and that is the process of crystallization process. Okay, so consist in addition of new atoms, ions or polymer string into the characteristic arrangement of the crystalline lattice. Okay, so during the process of crystal growth we are going to add some kind of atoms, some kind of ions or molecules, or we can say that polymer onto the substrate. Okay, and that kind of characteristic arrangement for the crystalline lattice. Okay, so which process was happening during the time of thin film crystal growth processes? Okay, so here I have mentioned one kind of figure, this figure, and these are the points. That point may be happening during the process of crystal growth. Which crystal growth? that is the thin film crystal growth process. Okay, so the process is nothing but absorption. That is, whenever we have going to deposit some kind of material onto the substrate, at that time the absorption process was happening. Okay, so let us consider the example, or let us look into this figure. Okay, and inside that figure, what will happen? These are red points indicate say molecules, or we can say that atoms. Okay, that is crystal atoms, and that rectangle indicates that point. This point, this point indicates our substrate. Okay, and if we simply put it our atoms inside that substrate or onto that substrate. So what is mean by absorption? Okay, and this process is totally a physical process. That's why this word indicates a physis option. Physis option. Okay, so what is mean by absorption? So it's a approaching atom can either be a reflected or it might be a absorbed onto the surface of substrate. Okay, means the atoms are totally absorbed onto surface of that particular substrate, and this process is dependent on the incoming flux of atoms or the trapping probability or sticking coefficient. Getting my point? So these are the concepts which we already discussed in our last lecture. But uh, what will happen exactly? So once an atom stick onto the surface, okay, I am talking about this atom. I am talking about this atom. Okay, I am talking about this atom. Okay, so once an atom stick to the surface, it creates a tension. Okay, so it's create a tension. It means uh, it's apply force in this direction also, in this direction also. It's like a surface tension process. Okay, it's like a surface tension process. And once an atom sticks onto the surface, it creates a tension, and tension is nothing but energy. Okay, it means it's completely attracting, or it may be a stretching processes. Okay, stretching means the atoms are stretched together. Okay, and in onto the surface, and it is due to the surface atom stretching their bonds is response to the absorption of atoms. Okay, it means they are attracting towards nearest atoms towards each other. Okay, and due to that reason, that atoms, that particular atoms are stabilized onto that particular substrate. Okay, and what will happen exactly? It is due to the surface atom stretching their bond in process to the absorption of atoms. Actually, it is a function of broken bond energy expose. Okay, it is a broken bond energy of export surface atoms, which depends on the crystal structure onto that substrate. Okay, so this is the process of absorption. Okay, so we can see here, this is the number one, and this atom, that is yellow atom, indicates a process of absorption. That yellow atom indicates a process of absorption. It means if we deposit that atom, the substrate uh, was, that means the atom was absorbed onto that substrate. Okay, and whatever we discussed recently, that is the concept of absorption onto the substrate of that particular film. Okay, okay, let's move towards the second point, that is the surface diffusion. Okay, it means that absorption atom, how that atom was diffused onto the substrate. Okay, that particular number one atom, this atom is how that can be diffused onto that particular substrate. Okay, so before going to start the point of surface diffusion, we have to know the concept of diffusion. So what is the definition of diffusion? Actually, diffusion is the movement of substance. Okay, listen carefully. The diffusion is the movement of substance from an area of high concentration to an area of lower concentration. Okay, and that is the definition of what? The diffusion. And why that process was happening? Okay, that second number process, I'm talking about the second number process, and why this process was happening. because diffusion happens in liquid or gases, because their particle move randomly from place to place. Okay, diffusion process cannot happen on the solid substance. It only happens on what? Liquid or maybe a gaseous. Okay, so diffusion is an important process for living things, and it is how substance move in and out of that particular cell, which we have already discussed in our recently lecture, last lecture, that means. Okay, so this is the second process. And what will happen exactly? What will happen exactly during the type of surface diffusion? That atoms, that absorb atom was diffused onto that surface, and overall the surface energy can be minimized if atom has enough energy and have time to diffuse at a lower energy site. Getting my point? So that diffuse atoms, okay, having a higher energy, okay, having a higher energy, having a higher energy. And at that if that particular atoms have enough energy, at that time what will happen? The diffuse atom to diffuse onto the lower energy side. Okay, and here onto the surface have a lower energy side. Okay, and due to that reason that particular atom was diffused. Okay, so diffusion rate increases with temperature. If we increase the temperature, it might be possible. It might be possible. Uh, the diffusion rate was increases. Okay, due to that reason, a diffusion length can be defined as, I already spoke in our last lecture that the diffusion length. Okay, how much percent of that particular atom was diffused? Okay, let us consider this is the atom. Let us consider this is the atom, second number one. And if we calculate the diffusion length, okay, in this direction or might be in this direction also. Okay, so there is one formula, to determine or to calculate the diffusion length. Okay, that atom can be diffused in this direction also or might be in this direction also. Okay, and that formula is nothing but a capital A is equal to small a under root of ksT. Okay, and here ks is nothing but a diffusion rate. Okay, diffusion rate means how much amount of atom was diffused onto the substrate, and what is the rate of that particular atom. Okay, diffusion rate. T is the diffusion time. Okay, how much time is required to diffuse that particular atom. Okay, and small a is nothing but a Hooke distance, means how much distance covered inside the substrate. Okay, so these are the two process. Number one is the absorption, number second is the surface diffusion. Okay, now let us move towards the point of chemical bond formation. This part. Okay, this part. Okay, these all six process are the very important or major stage. Okay, during the crystallization process. Okay, during the thin film crystal growth processes. Okay, and now we are talking about the chemical bond formation. Okay, so during the time of absorption, the physisorption was happening. Oh, physisorption means these are the physical process, but here the third process is chemical bond formation. And here inside the bracket, one word is written here, that is the chemisorption. Okay, and inside that process, this thing was happened due to the chemical reaction. Okay, so what is mean by chemisorption? We can easily seen in this figure, second number figure. We can easily see the chemisorption is the adsorption by formation of chemical bond between adsorptive and adsorbent. Okay, I'm not talking about the absorption, I am talking about the adsorption. Adsorption. Okay, that is ADSORPTION. Okay, adsorption, not a absorption. Okay, and that is the chemisorption. Okay, and inside that process, molecule can be attracted towards the each other. That is the adhesion process or and another one is the substrate molecule attraction, because in molecule attraction it means if inside the substrate or onto the substrate, if suppose that there is one molecules are present, and if we deposit some kind of atoms, so that particular atoms can attract onto the that another atom. Okay, and that both the atoms or both the molecules is an a similar kind of atoms or similar kind of molecules. Okay, keep in your mind that molecule chemical bond formation, inside that chemical bond formation, this molecule formation, during that process, the both the molecules uh, are in a same categories. Okay, are present in a same categories, means both the molecules are similar. Okay, but during the process of substrate molecule attraction or a chemical bond formation time, the substrate is in a different type, different kind of materials are used, and molecules are in a different kind of materials. Okay, so chemisoption is nothing but a adsorption by formation of a chemical bond between adsorptive and adsorbent. Okay, so we can easily look here in this figure. Okay, so this is the surface, this is the substrate, and this is the surface. Okay, and what will happen exactly here? Here, during the chemical bond formation time, the uh, here the substrate, they are they are catch the molecules on in towards the substrate side during the substrate side. Okay, and these are the binding sites. This process are indicates a binding site. Okay, it means that they can bind the atoms, they can bind the molecules towards the substrate side. Okay, and and it is observed that, and it is a obvious that it is a irreversible process. It is a irreversible process. Why I am talking about the irreversible process? Because whenever atoms are bind onto the binding side, it cannot move again. Okay, it cannot uh, release again. Okay, and due to that reason, we can say that this is the irreversible process. This is the irreversible process, or we can say that it is a monolayer adsorptive at active surface site. Okay, it is a monolayer adsorption at active surface site. Okay, mono means single. Okay, mono means single layer. Okay, and during that chemical bond formation time, it may be happen or it might be possible that the monolayer adsorption at active surface site. Okay, so which one is the active surface site? This total site is a active site. Okay, this is the total site is the active site. Okay, and here the monolayer adsorption might be possible during the active surface site. Okay, so during the chemisoption process, all the atoms, all the molecules are bind into the binding site. Okay, keep in your mind that all the atoms, all the molecules, all the ions, or all the external crystal, whatever we want to deposit onto the substrate, that atom, that molecule can bind onto the binding site. Okay, this is the binding site. I already shown this is the binding site. Okay, so one more thing was happening during the chemical bond formation time, and that is the reactive gases at active metal site at temperature above room temperature. Okay, and if we go towards the physics option side, so it that time inert gases are required, but here reactive gases are required. Okay, so during the chemist option side, or if we think about the chemist option process or chemical bond formation process, the carbon monoxide means CO, H2, ammonia, oxygen, okay, sulfur dioxide, on platinum, palladium, nickel. Okay, this kind of gases are used onto the substrate of platinum, palladium, nickel. Okay, these are the gases are used during the process of chemical bond formation. That is chemist option. But if we think towards the physics option side process, that is the absorption process, at that time I think it might be used inert gases, that is the argon or maybe a krypton, xenon, radon. Okay, and at the temperature range is around 77 Kelvin, or it might be 87 Kelvin. Or if we use the CO2 at 273 degree Kelvin, it means it's 0 degree Celsius approximately. Okay, that so this is all about the chemical bond formation process. Getting my point? So okay, so this is all about the uh, process of thin film crystal growth processes. Okay, or that is the theory of thin film crystal growth. Okay, so today we discusses the point of absorption, surface diffusion, chemical bond formation, and tomorrow we will try to cover on the point of nucleation. Okay, so see you tomorrow.